OpenStax second edition, college physics second edition, chapter 2, problem number 23. Here we go. So let me just read the problem to you. I have it right here. It says a light rail commuter train accelerates at a rate of 1.35 meters per second squared. Check. How long does it take to reach a top speed of 80 kilometers per hour starting from rest? B, the train decelerates with a rate of 1.65 meters per second squared. How long does it take to come to a stop? C, in an emergency, it can stop in 8.3 seconds. What's the acceleration then? So we've got 3 parts. Let's just get to it. Now, you might think right away, and you should, well, I kind of like drew a picture, right? I like to think about that picture. So let's just actually expand on that picture because I want to draw this as 1, and then it's going to come up to here, 2, and then it's going to come down here to 3. So it's going to speed up, reach a constant max speed, and then slow down. And so just my labeling, right? V1 is the velocity here, V2 is the velocity here, V3 is right there. This is A1, the acceleration during there, and A2 is the acceleration when it's going forward. Now you don't have to draw that picture, but it kind of helps to get a map of where you're going, right? And the drawing of the picture, I think, is kind of like my first step. I like to do that. And the next thing I do is I write down what I know, and I write down what I'm looking for. So I know the acceleration, 1.35 meters per second squared, just for the first part. I know the initial velocity is 0, and the final is 80 kilometers per hour. Ding, ding, ding. That's what you should say in your head, right? Because like, well, look, I have meters per second squared. I have kilometers per hour, and that unit mismatch is going to be a problem. So let's just go ahead and convert our velocity to meters per second, and then everything will work out better. So let's do that. Again, I'm going to write it over here. V2 is 80 kilometers per hour. And to convert units, we multiply by 1. So let's get rid of the kilometers first. And again, you can do this in your head, but I'm just warning you that if you're not 100% sure, I would just write it out. So I'm going to write this as, I know I want to put kilometers on the bottom. And I know kilo means 1,000, so that means that there are 1,000 meters in 1 kilometer, although we say kilometer, and I don't know why. Okay, but there the kilometers cancel. Now I want to get hours to seconds. We could do this in more than one step, and I will, right? So I can say, well, there's 1 hour is 60 minutes, but then I need to convert minutes to seconds. So I can say 1 minute. Am I running out of room? I made it, okay. Is 60 seconds. So here, the hour cancels, and then the minute cancels too. So I'm going to get that in seconds. Let's just calculate this really quick. So it's going to be 80 times 1,000 divided by 60 times 60 meters per second. Now, I'm just going to write this out. So 80 times 1,000 over 3,600. And then I'm going to go ahead and say, well, that's the same as 3.6, right? I just did one of the things in my head. I don't know why I did that. You don't have to do that. Okay, so let's do this in our calculator. So 80, 3.6 divided by 22.2 meters per second. Now, if you want to check and you don't feel comfortable, if you just type in 80 kilometers per hour in meters per second in Google, boom, it'll give it to you. Okay. I actually have had errors in there, but it usually does a pretty good job. Okay, so that's that. So let's just put right here 22.2 meters per second. So now we can go back over here. We're trying to find delta t. So for delta t, I can use the definition of acceleration. So we define the acceleration as delta v over delta t. So that's going to be v2 minus v1 over delta t. I want to find delta t, so I can multiply both sides by delta t. I get a delta t is v2 minus v1, and then I'm going to divide both sides by a. I get delta t is going to be v2 minus v1 over a. So let's just go ahead and plug in our numbers. Our final velocity is 22.2. I'm going to leave off the units for now just to make it look a little bit cleaner. Minus the initial velocity of 0. I've said this before and I'm going to say it again. If you got to be very careful. A lot of people put, oh, acceleration is v over t. That is totally not true. Don't do that. You're going to get yourself in a lot of trouble. Pretend like I didn't even write that. Okay. But I did. Okay, divided by the acceleration of 1.35. And I'll go ahead and put it right here, meters per second squared, just so you can see that the units do cancel, right? So the meters cancels, one of those seconds cancels, have 1 over seconds, so I do get seconds. That's a good thing. Now we can put this in our calculator. We get 22.2 minus 0 over 1.35, and I get 22.2, 1.35 divided by, I get 16.44 seconds. So if this is a test, and you want to show all this kind of work. You don't want to just say, oh, I'm going to put the numbers in and I'm not going to put the units. You want the units, you want to show your work, you want to show your starting equation, show your starting ideas and everything. So over here we can put this in so we have a complete thing. 16.44 seconds. Now, for part 2, we have a negative acceleration. We want to find the time. Well, we're still going to use this, right? We're just going to change this to, we're going to start at V2 and end at V3. So this is going to be V3. This is A2, and that's V2. So we know V2 is 22. V3 is 0. We're going to stop. But still we have the same thing. The other difference is, now it says deceleration. Deceleration is something that we actually rarely use in physics. It just means slowing down. Really, acceleration is a vector. So when we get into two-dimensional stuff, the deceleration doesn't really make that much sense. So we would just say, in this case, we have positive x, negative x. The acceleration is in the negative x direction, which means if your car is moving in the positive direction, then it's decreasing in the magnitude of the velocity because the acceleration is in the opposite direction. Okay. So I don't like that word. I don't like deceleration. But over here, we can just change that. 2, 3, and this is D2, 2, 2. So let's just go ahead and put in our values. So this is delta T2. It's going to be equal to V3, which is 0, minus V2, which is 22.2, divided by the acceleration of negative 1.65. And here we have meters per second squared. Again, they cancel. Now you also notice that we're going to get a positive time. And so I put in a negative acceleration, but my final velocity is 0 minus my initial velocity, so the top's negative 2. So I have negative over negative. So that's really good. If you get a negative time interval, it's not absolutely crazy, but it's a little weird. Okay. So let's just put that in, delta T2. I'm going to put it in my calculator. I'm going to skip the negative part because I know 0 minus that's negative 22.2, and I know the negative cancels. So 22.2, 1.65 divided by, I get 13.45 seconds. Now, notice that the acceleration slowing down has a greater magnitude than speeding up. So it's going to take longer to speed up to that maximum speed than it will be to stop, right? And that's what we got. This is shorter than that. So it's a little check. We can just check that, right? It's good to check these things. Finally, we want to find the acceleration with that time. Again, we'll go back to our definition of acceleration. I'll just start over that stuff. A is going to be equal to delta V, delta T. And so this case, we're stopping. So the final velocity is 0 minus the initial velocity of 22.2 meters per second squared. And then we're going to say delta T is 8.3. And this is meters per second squared. So we do, no, it's seconds. And so we get meters per second, which is a meter per second squared. So we can just plug this in. It's not too bad. It will be a negative acceleration according to my rules, but I think they don't want that. So I'm going to say 22.2, enter, 8.3 divided by, and I get negative 2.67 meters per second squared. Let's put it right here. Negative 0.67 meters per second squared. Okay, that's it. Now, just a quick note. Units, don't forget about units. Start with the definitions, right? We have only a few fundamental definitions. Velocity is the change in position with respect to time. Acceleration is the change in velocity with respect to time. And if you write it that way, you can make it really far without having to do extra stuff that you don't want to do. So, thumbs up.